Okay, what you learn. Today, this is lesson 5 of Unit 1, second semester, 7th grade math. We're going to be talking about unique triangles, and we're going to construct some unique triangles using 3 different methods. Okay, so what you're going to learn today, to construct triangles from 3 measures of angles or sides and evaluate triangle characteristics to distinguish unique triangles. So the new vocabulary today is unique triangle. Why learn this? If you know all the side length measures or all of the angle measures of a triangle, you can use a compass, protractor, and a ruler to construct that triangle. Triangles can be drawn using a compass, protractor, and a ruler. So here's an example of a protractor. And if you notice, it counts by tens, but it has markings in between. So it's a little different than the one that you have. But from the bottom of the protractor, if this was the bottom, this is the point that you would actually measure from. On your protractors, you have an opening. If you'll take a look at your protractors, you see that opening? Okay. And then you have what we'll call the horizontal, a line that goes right across, and it should connect 0 degrees on one side and 0 degrees on the other side. Do you see that? Okay. So we're going to talk a little bit more about how to measure angles using the protractor later in this lesson. So let's go ahead and get to the first activity. You should have 3 sheets of paper on your desk. What I need you to do first is I need you to use your ruler, and I need you about halfway down your paper, I need you to draw this line. So your line should be somewhere about here on your paper. And it needs to be 5 inches in length. Got it? Don't make it all the way to the edge because we're trying to draw it so that our picture's centered into the paper so we're not running out of paper space. Okay? So if you take a look at what I got up here, try to draw your line about halfway down and about somewhere in the middle of the page. Okay, once you have that, and I'll go ahead and do this on the smart board. Okay. Using the virtual tools, that's about 5 inches using my ruler. I need to label my line segment. So my line segment is segment BC, that's 5 inches. So on one end, label it so that it doesn't, label the end point so it doesn't make your long line actually longer. So be very precise about this. My last class, when they measured their final drawing, a lot of them did right on the money, had it exactly perfect. So if you're very thorough, your pictures are going to turn out well. So this is line segment BC. The next step is we need to use our compass to measure our opening of our compass so that it is 3 inches from the tip, the spike, to the pencil tip. So using your ruler, you're going to open it up. You use your compass, and you're going to measure the pencil tip to the spike so that it is exactly 3 inches open. Now, when you draw with your compass, hold this pointed part like a pencil. You're going to take the spike and put it on the end point, and you're going to make your arc. You can move your paper to make the arc, or you can move your wrist to make your arc. It's just a light arc. It doesn't have to be terribly dark. We're just using these as reference points to draw our triangle. Okay? So I'm going to go ahead and demonstrate this on the smart board. So at point B, I need a stick. Okay, here we go. All right, so I'm opening my compass so that it's from about 3 inches. And if you notice, it's a little bit less, so I need to open a little bit more. And do you see now that I have my compass open to 3 inches?
Can I get a new ruler? My numbers are fading.
All right, so I have my compass open. Now what they want me to do is they want me to take the spiky part and they want me to stick it on the B, point B. So let's go ahead and do that. Point B. And I'm going to make an arc. An arc is not a full circle. It is a semicircle. It's a part of a semicircle is actually half of a circle. It's an arc that is exactly half the circle. We're going to make an arc that's less than a semicircle, small. So I'm going to draw my arc in red, and we didn't make it so that it's covering enough area so that when we draw our other arc, it's going to intersect with this arc. So I'm going to go ahead and draw my arc, and I would say that's about enough. Okay? Does anybody have any questions? Now, I would suggest resist grabbing both ends of your compass. Open it up exactly 3 inches. Only hold the spiky part, and then rotate your paper to get a nice good arc. Got that? If you don't like that, you might want to just use your wrist to get the arc, but try not to hold both ends of the compass, or you'll open your compass and you'll change your measurements. If your compass is floppy and the hinge is loose, let me know. I could tighten down the hinge for you. Okay. So the next thing I need to do is I need to measure another arc, except for this arc, it says in the directions, I need to open my compass 4 inches. So open your compass to 4 inches. Place the tip of the compass at point C and draw an arc above segment BC. So we're going to do the same thing, except for our compasses need to be open 4 inches this time. Okay? Where the arcs intersect, we're going to label that point A. So let me go ahead and measure my arc first. Looks like I might be just a little bit too much. All right, there we go. All right, now that I have my measurement, I need to take the spike and stick it on point C. And now I'm going to make another arc so that the arcs intersect. Okay, do you guys see what I just did? So this arc is a 4-inch arc. The first one was a 3-inch arc. And now they've made an intersection that I'm going to label point A. You need to remeasure and make sure that your line segment that you start out with was actually 5 inches. Okay, I'm looking around. I see some correct drawings. There's a few of you that might want to go back and double check your measurements. Okay, question in the back?
Are the arcs themselves supposed to be a specific length?
No, they're just reference points so that we can draw our triangle. So now that we see where they intersect, now we're going to draw line segments. And the line segment AB is going to be 3 inches long. And line segment CA is going to be 4 inches long. So now do you understand why the arcs were there? Okay, it's to help us figure out where line segments that are 3 inches and 4 inches will meet perfectly. Does that make sense?
Yes.
So now we're going to go ahead and draw those line segments to make our triangle. going to draw segment AC. Okay, here's segment AC. Let me go ahead and erase that. A little excess. So, now that I have completed my drawing, you see in green we have triangle ABC. Okay, and so you should have something that looks pretty close to this is, what kind of triangle is this? Does anybody know? Scalene triangle, because none of the sides are the same. And actually, I don't know, these two, angle B and angle C are acute, and angle A kind of looks like, what kind of angle does that look like? Looks like a right angle. Okay, let's check. We're gonna verify this later in the lesson. But this is a scalene triangle. Okay, I'm going to copy this, and I'm going to paste it here so we can make a comparison with our three triangles. So that's the first triangle we drew. Now we're going to go draw a second triangle. Here it is. All right, this time we're not going to use the compass. We're just going to use the protractor and the straight edge. Okay? Yep, do it on a different paper so we can make a comparison. It'd be nice if we had three different separate sheets so we can overlap them and maybe hold them up to the light and see and compare them. All right, so now we're going to start out with line segment CA, and line segment CA is going to be 4 inches in length. So let's go ahead and draw line segment CA just like we did before, and it's going to be 4 inches in length. Yeah, that's probably the best place to do it. Yeah. Right about 4 inches. Okay. Once you've drawn your line segment, make sure you label it. C, A. So now we have line segment CA. Okay, the next thing we're going to do, we're going to actually use our protractor now. So if you recall earlier, I said we're going to actually practice how to measure angles out with the protractor. We're going to create an angle, and the angle is going to be 90 degrees, but we have to measure out 90 degrees. So here's what we do. On your protractors, you have that open circle, that little opening. You need to line that up on point A. So I don't have an open circle on my virtual compass or protractor, so I line up this little T. Okay? Now what I need you to do is you're going to mark off the 90-degree mark. Directly above, you see there's 90 degrees. Do you guys see that? Okay, if we were measuring another angle, you would find that angle and mark it off there. Now, this is just a reference point again. Do you guys understand? It's just for reference. It's not necessarily the length of the side we're about to draw. So I'm going to go ahead and I'm going to put my ruler in position so I can draw my 90-degree mark. Okay, so we need to make sure that this is 3 inches long. All right, so from that mark, we're going to draw a 3-inch line. And I actually need to, I'm going to go ahead and draw it, and then I'll erase off any excess I have. So here is 0 inches. And then I went a little bit too far, so I'm going to go ahead and erase that extra that I had there. Now I have a 3-inch line segment, 1, 2, 3. And I need to label this endpoint B, the end of this line that I just drew. So guess what? I have one more line segment to draw. I need to connect line segment BC. Okay, drew a little bit too much, so I'm going to erase that. And then now I have my second triangle that I'm going to put on my last page for comparison. Okay, that's my other triangle. There's my first one and my second one. Let's go back. The last one. Now, for this last one, we're not going to use anything but angles now. We're not even going to really, you can measure off whatever you want. Try not to pick a side that's too long. I would say try to keep it between 2 and 6 degrees, okay? If you make it too small, it's going to be hard to get an accurate measurement. If you make it too big, it's going to run off your page. But you guys choose how big you want to draw it. Keep in mind that your compass can only extend but so far. We're not even using our compass. You don't want to make it too big that it's going to run off the page. So we are still going to construct this. Okay, so draw our line segment AB. It doesn't even tell you what size AB has to be. You just pick for yourself. I'm going to choose 3.5, just to be a little different than what we had before. Okay, I think that's about 3.5. Okay, I'm going to make AB 3.5. Here we go. There's A. Here's B. All right, so the next thing we need to do, and this is why I said try to grab the protractors that were graduated for every degree, is they want us to measure off at point B as the vertex 53 degrees. So here we go. Oops. All right. 53 degrees is about okay, here's 50. If you look here on the left of my protractor, 0, 10, 20, 30, 40, 50. I don't know if you realize this, but with each degree that's an acute angle, just below it is an obtuse angle, and those two angle pairs are, what are they? Do you remember? What's the word? What's that? Supplementary, because they add up to be 180, okay? So you can have acute angles that go to the left or the right. That's why you see the same angle on both sides. Does that make sense? Okay, so we're trying to measure out an angle that's 53 degrees. 53 degrees, here's 50. 1, 2, 3. That's about 53 degrees. Okay, I'm going to use my ruler. And they're not asking you to measure it off. They're just wanting you to draw a line segment that's 53 degrees to line segment AB. So I'm going to do that right now. I'd say that's pretty close. All right, now that I have 53 degrees marked off, I'm going to move my protractor out of the way. I'm going to go ahead and draw my line. Oops, didn't work this time. All right. Okay, next thing we need to do, they want us to go to vertex A, lay your protractor down with the straight side resting on segment AB, draw a 90-degree angle using point A as the vertex. So we're going to do the same thing as we did before, except for now we're on vertex A. I need to mark off 90 degrees. 90 degrees is directly above. I'll get my ruler lined up, and I need to draw it so that my sides intersect. I'm going to move my compass out of the way. Okay, there we go. All right, now that I got that drawn, I'm going to label that intersection C. Oops, didn't grab everything. Copy this. All right, so here's my third triangle. And I'm going to go ahead and erase off some of the excess. All right, so here are the 3 triangles I drew. Now, these use some measurements for the sides, and this is kind of the foundation for some theorems you're going to come across later in geometry on how to compare congruent triangles that are the same without measuring all the sides and all the angles. There's some things that you can measure pieces of it, and you can and you'll know that the triangles are the same triangle. There are some ways to measure triangles where you know that they're not necessarily the same triangle, but you know they're the same shape, and that means they're similar. So that's kind of what we're going to talk about today. So for this first triangle, I'm going to go ahead and rotate it and then overlap it with our second triangle. Pretty close, right? It's not perfect, but I'd say it's pretty close. Okay. Now the reason why they're the same triangle is because we use some of the same sides, right? I think we use length 5, 3, and 4, right? Here we use length 4, 90-degree 3, and then that became 5. Take a look at your second triangle. Can you guys measure the hypotenuse, the side opposite angle A? Can you measure that? And if you did it correctly, that side should be about 5 inches.
You said the first one?
The second one. No, measure C to B to C. That's the longest side. It's 5. You got 5. Who else got 5? Okay. A lot of you got 5. So you're very precise when you're drawing your triangle. Perfect. You got the exact result that we're looking for. So these triangles are not only are they similar, the same shape, they are congruent because they're the same size and same shape. Now, for the last one, everybody's going to have a different result because everybody chose a different length for that first line segment. Do you guys remember? But what's going to happen is with the smartboard, I can shrink it down and show you that we still have the same shape. It was just a different size. Pretty good, right? Okay. So it was the same shape, just a different size. Now, if I would have chose 3, it would have been the same size because I would have had just picked up the same size to start with, and then all the angles would have fallen into place. And it would have been the same size. But I chose a different size intentionally just to show you that, hey, if you use the same angles and you have the same angles that are measured, it'll be the same shape. It won't necessarily be congruent, but it will always be similar. Do you guys remember similar figures?
Yes.
Okay, so that is essentially the point of our lesson today on drawing constructions. Okay? Any questions? Ben?